Hello, Michael Moyer here, CEO and co-founder of Ocular AI. In this demo, I am going to show you how we essentially ingested a very popular dataset into our lakehouse, curated it, organized it, indexed it, and then annotated that data, versioned it, and then trained the model on top of that data that was actually able to identify objects. So the dataset that we're going to work with today is this dataset from New Image, from New Sense by Emotional. It's a very, very popular dataset that has a massive, massive amount of data, 1.4 million images. We just use a portion of that to annotate. So anyway, let's jump into it. The first thing first on Ocular is you need to be able to ingest the data into the lakehouse. So you can do this through the local storage or through your buckets. In this particular case, we use the local storage to ingest the data. After ingesting that data, we moved it into this catalog and we organized it in different folders with the team, which is what you're seeing here, the front view. This is basically the front view of the vehicle or from the data set that you actually saw. So you can sort of like explore the data and organize it and move it around and play around with it to get a visual understanding of how your data is. The second step is we index that data into different indexes. An index on our lakehouse essentially allows you to get a semantic understanding of the data, makes it searchable. We do have computer vision models and foundational models that actually help us generate embeddings on that data, and we're able to actually search it, and we're able to also organize it. So which is what you're seeing here. Second step is you need to create a project. We have a project here. The first thing that you actually get is this very, really beautiful overview page of the project, which shows you the label distributions as time goes by, and sort of like the jobs and the number of frames and the number of versions that this project has. As you can see here, in this project, we're actually working with 5 labels: a car, human, bus, road path, and traffic lights. It's a very interesting objects that we actually have in the dataset. The first step obviously is to create a batch, but what you're seeing here is we've basically annotated most of the frames, and most of the frames actually moved to the dataset column here. But I'll show you how the annotations look on the canvas. So as you can see, some of the images are annotated here. The annotation that we did on this particular project is a combination of humans and also our data labeling agent here, which you're seeing. You can essentially choose what you want to basically label, and you can essentially run a test on the frame and essentially try to annotate huge amounts of frames in a short period of time using the agent. Okay, after that, we were able to move the data to the data set, and then we created versions. A version is basically a snapshot of the data at a particular time. So what you're seeing here, for instance, is that we had this version that has 236 images, but we also have other versions that have higher frames. So what that simply means is that you can keep on adding fresh data and create different versions to train models. Okay, so each version has a distribution of the dataset. As you can see here, you can play around with this and you can see which frames in that version. You also get a sense of the label distribution. But I think what's really important for this particular demo is that you can actually train different models on a particular version. So what you're seeing here, we trained this YOLO model, segmentation model, on this particular version, and we're able to kind of like get the numbers, and we can explore the graphs here and see how this model performed. We can also get an advanced graph such as these ones, where you can see the precision curves, the recall, confidence curves, the precision recall curves to get an understanding of how the model is performing. You also have these 3 graphs, which are the box loss, class loss, and DFL loss. So you can play around with that in a very interactive way. You also have this confusion matrix, which gives you an understanding of how your model performed on different labels. Compare that to the background. We also do have this advanced background confusion matrix where you can actually get more details, and you can actually download this. And then we have this really interesting overall result graph that you can actually generate once your model is trained. Then we have a couple of more, graphs such as the F1 confidence curve. I think what's really interesting about Ocular is that we actually also give you a visual output of how your model performed. So you can see this model was able to identify road paths and buses and cars. There's humans there as well. There's very few humans. So it's very, very interesting. But anyway, you can view the model performance across different versions of the model of the data set. So you can play around with that, and you can see the different curves. But you can also see the training results on this workspace level, where we show you an overall view of sort of like model runs that you've run on different projects. And you can basically open one and play around with the graphs that we actually just saw. So very, very interesting. In addition to that, you can actually initiate a training run right here by selecting the project and basically selecting which version you want to run on. So let me say training 100 here. Training model on version 1, dataset. I'm going to use a yellow segmentation model and make this medium. I can basically start running a model run there. So as you can see, it's actually training, and I can begin to sort of like see, wait for the results of the model to essentially show up as time goes by. So anyway, very interesting project that we have here on Ocular. You saw the results, you saw the training. I walked you through everything from ingestion into the data lake, all the way to cataloging the data, curating it, creating indexes, and being able to annotate the data, and also being able to train it. So we can't wait to see what you can build with this training. This is also GPU hosted, so every time you train on Ocular, you have a constant supply of to GPU. So very, very interesting. We're really excited to roll this out. Thank you so much.